DRay 110. You should be in the class if you are logging in correctly. Remember, you have to log in just like Brightspace. So you have to log in using your login.cuny.edu login. And that's why I told you multiple times, download the app. Because if you download the app, it'll be easier to maintain that login. Don't try to go through the web browser. So first things first, download your app. But you should be automatically added to the class. Are you in Chem 113 or 114? It's okay to wait, but what class are you in? 113 or 114? So Gen Chem 1 or Gen Chem 2? I just want to make sure that you are in the class, because sometimes when students get added late, they get missed in terms of their getting added to the class. Cancel. Let me check that for you then. Yes, you are in. So, what you need to do is just make sure that download the app and make sure you're logged in using your app. So you should be logged in using your first name, last name, and it's usually the last 2 digits of your CUNY ID at login.cuny.edu. And it requires the same password as the Brightspace does. And while I'm here, Great! I'm so happy. So, Dwight, the questions that you should have, any questions you should have that are course related should definitely go in the question and answers channel. So, this channel right here. So Rachel, if you are a student at Queens College and you want that bonus graded, you have to submit it in that mailbox by 5 p.m. on Friday. Because when I'm out of town, a student will be pulling everything out of that mailbox and scanning it and sending it to me at 5 p.m. on Friday. And it'll be graded and posted. I cannot accept it electronically because if you type your homework, then ChatGPT can type your homework. So it has to be handwritten. And I cannot require that students have the ability to handwrite on items using their computer. I have that ability, but I can't require it of students. So if you have that ability, then we can make arrangements for that. But I will not accept typed homework. So. Now, that doesn't mean you have to submit it on Friday. You can finish it and submit it on Thursday. You can finish it, submit it on Wednesday. In other words, you can submit it anytime you're on campus. The Friday deadline is at 5 p.m. on Friday. All the homeworks in the mailbox are going to be collected, scanned, and that's it. That'll confuse anybody. You can stay down there so I can keep. Well, then tomorrow I will talk to the class about allowing homework to be submitted electronically, but it must be in a particular format. So I'm flexible in that, but I have to have proof you at least wrote something and it's not typed. So I'll make some adjustments on that homework wise in terms of policy, but it'll be very clear that if you type it, it's not graded. So. And also, one of the things that can happen is, like, I've had students that take this policy and then they send me 20 photos that I'm supposed to pick through one at a time. So it'll be one of those things of either you can write it, I'll probably push it out as a OneNote file, and you can either do it in OneNote and write it, or you can submit it as a single PDF file. But there are going to be things like, I'm not going to grade 20 pictures type deal. It's surprising when you open up electronic submission, all of a sudden you get stuff, it's like, I can't grade this. What do you expect me to do with this? So that's why I usually just try to do, submit it to me in person, because then I know it's a single sheet of paper and it's gradable. It is amazing. And students are like, well, you didn't say we couldn't do it that way. I'm like, well, I didn't think I would need to say you couldn't do it that way. Oh, so it can be a little amusing. So I have a Word file shared that you are welcome to, yes, I see you, buds, that you're welcome to add to your evening goals. And then as you finish them, you can use the either highlighter or there's a text strikeout to strike out to show you completed your goals. And when you do that, I will congratulate you on completing your goals. So if you see something written that's obviously a goal, that's a student that's completed a goal. So create a new student. If it says just student 2, that's not in use yet, basically. So I could add multiple students. Now, my goal. I see you, Emerald, and I will take you out and then feed you in just a minute. But I'm going to get this goal accomplished first. hi Samson, welcome here. So again, the 100 questions, the 100 questions list those are all of the suggested homework for the chapter 1 that we're currently in. I'm going to randomly pick some of those problems. I'll probably use an online random number generator to do that here shortly. And then once I do that, I'll write the homework based on those random selections of questions from that list that I gave you. And then when I write the exam, the same thing will happen. I will randomly pick some of the questions from that homework, and those will form the basis of the exam. So, you know, obviously I've got a limited time. I'm only giving you guys an hour to try to do the homework online. So for that particular homework set, so for this particular homework set, I'm probably going to balance it. There we go. So for this particular homework set, I'm probably going to balance it. I generally, when I'm assigning homework, I don't pick a lot of the qualitative problems for homework, and the reason for that is because that's mostly definitions and things you can memorize. So if I'm going to pick a qualitative problem, it's going to be something I can link to a quantitative problem, where I can, for instance, use one of these quantitative questions and then ask some of these qualitative questions based on that quantitative question. So I might do something like that where they're linked, which they are. So for instance, 36, 37 are probably linked to 38, 39, so I can probably link those. But I'll also end up so, you know, I'm very aware of the time we've got in class. So and since for you guys we don't have the chem activities for this first chapter because there aren't any that really go with the first chapter, we're using just textbook problems. But for instance, I know I haven't yet covered accuracy and precision. I know I haven't yet covered significant figures or addition, subtraction with significant figures. So all of that homework's out. We have talked a little bit about density, and I've defined it, but we haven't really worked problems in that. So since the homework comes towards the end of the class, I might go over some of those problems in class because I know they're going to be part of the homework that I give you guys. But yeah, since we haven't covered a lot of the quantitative problems yet, I may, for 113, since the homework is tomorrow, I may actually pull it where it can be submitted on Friday and not penalize a late fee on it, because that way you have a little bit more time to complete it after we've gone over some of the math, which we will do in lecture before I hand out the homework. So as the semester goes on and we spend more time doing problem solving during lectures, it's going to be really a lot easier for me to hand out homework, because I'll have confidence that I've shown you how to do it before I hand it out. This one, not so much. And in fact, after having done the 114 calendar, I may go back and look at your calendar and shift homework around just a little bit more because of that. So that's something I need to look at, and will look at and put on this to-do list. So I'll put that on my to-do list. So there is a shared Word document. You're welcome to take one of the goals and give me your goal for the evening work along. Once you've given me that goal, I'll post it. So there is that. The suggested homework is where I'm going to pull the assigned homework from, and is where I'm going to pull the exam from. So if you do your suggested homework and the suggested chemical activities, then you will be prepared to finish your homework in class. If you haven't completed the suggested homework, then when I hand out the homework in class, you may not be ready to complete it because you haven't looked at it. But this first class where we're just getting started, I don't suspect everybody will have completed this. But the truth is there's going to be about 100 problems per chapter, and we're going to cover a chapter a week. So is it reasonable to consider that you're going to do all of the homework in this class? No. The point is can you do enough homework problems where you are comfortable enough with the material so that when you get the list of homework that I pull, even if it's not a problem that you worked, you still can work it in a timely manner. So for instance, say you've worked a bunch of unit conversion problems, but you didn't work them all because there's a ton of them. But then I pull a problem you didn't work, but it's a unit conversion problem, and you're like, oh, it's just a unit conversion problem, and you just work it. Because you've worked a bunch of those problems, you know how to work that problem, and so you can still reasonably do that homework problem and get it done in class and not have to do it later. Make sense? In other words, I don't expect everybody to do all of the homework, but if you work problems until you're comfortable with that type of problem, then you'll be able to work the homework problems that I assign, even if you didn't already work them. And by giving you 100 problems, it means I have a significant number of problems I can pull from when it comes to writing exam questions and quiz questions and all sorts of other questions that I need to write for going forward. But one of the complaints that I've had in the past is, well, we didn't know what was going to be on the exam, so there's all of the problems. I promise you I will not be making up stuff that's not in these problems that I've assigned. So if you legitimately worked every problem assigned, then you have worked the exam. Now, if you do that, I fully expect you to make 100 on the exam just because you've worked so many problems. You can work anything I give you, but I'm fully aware that there is a balance. But, you know, the body doubling sessions in this course are 6 hours a week. The lectures are 4 hours a week. That's 10 hours a week. For a 4 credit hour hybrid course, I should be doing about 13 hours a week of work with you guys. So that means you need like one more 3-hour body doubling session, and that would be the full amount of time you should need to study for this course. Well, you're welcome to hang around for body doubling. I am about to take a 10-minute break. My dogs are pawing at me, so they need to go outside real quick. And then they need fed. They're hungry, and I need to heat me up something because I haven't eaten all day. So I will be back in 10, but I'm going to leave the stream open. For the person who said keep reading through textbook, I suggest start trying to work homework problems and allow the homework problems to guide your reading instead of trying to read and then do homework. So I would start trying to work on the homework problems instead of reading the textbook. It'll be more efficient. Okay, well, that's a good question, Ju Chung. Um, okay, so give me just a second to try to get something set up. I understand. Give me just a second. I'm going to try to get something set up a little bit better in terms of this live thing. Uh, there we go. Okay, so okay, that gives me that. And then There it goes. I'm still on your question. I'm just trying to get it set up where this is easier to do in the future. So, while I'm waiting on that, the truth is like all nomenclature, some of the rules of nomenclature are because that's the rules. And I know for a lot of us that are both scientists and rebels, it's like, well, why is that the rules? And that's a perfectly understandable question. The truth is, why is that the rules is more because IUPAC, our governing body that dictates chemical nomenclature, says that in general, when we are naming branched alkanes and we have an alkyl, a carbon group hanging off of a main chain alkane, the way we're going to name that is we're going to replace the A and E with YL. Now, could they have used something else? Yes. They just chose not to use something else. So that's just one of those things where, finally. Yay, we got it. So that's just one of those things where they're specifically choosing a particular rule. So you could kind of say, you know, why is this the way you do it? It's kind of like saying, why do we have certain laws? It's because, well, historically we did it this way, and it just kind of gets transported up and through. I did look up where meth came from. It's from the Greek. Okay. So, in other words, it's more of in line with history, is what dictates and governs our understanding of alkanes. But now I can at least so when we have an alkane, so this is methane, and then we all of a sudden make a long chain alkane. For this one, the very first thing we have to do is we just have to count the number of carbons in branches. So in this branch, we have 4 carbons. In this other branch, we have 5 carbons. So this branch is our dominant. So this is a pentane. Now, this other branch here, that is an ethane, but because it's attached to the pentane, we drop the AN, add a YL. So this is an ethyl pentane. And then in terms of where this ethyl pentane is located, 1, 2, and if I were to number this from the other direction, I'm going to use a slightly different color. 1, 2, 3, 4, 5. So 2 is the lowest number. So it's a 2-ethyl pentane. Now, redrawing this with the pentane as the top, we have to name them. You have to find the longest chain of carbons because that is your primary name. So the very first thing you have to do is figure out what is your longest chain. And when you're first learning this, I recommend you circle your longest chain after you figure that out, because that makes naming it easier. Because once you've named your longest chain, everything else is attached to that longest chain. So now I've redrawn this molecule. So to there. And now if I look at this, I can see that I have, there's one thing attached to this central carbon. There's one thing attached to the central carbon. There's one thing attached to the central carbon. And for this purposes, there's one thing attached to the central carbon. So this thing is chiral because I have 4 different things attached to that carbon. So now I would have to determine, technically the 2-ethyl pentane I have to tell if it's if it's R or S. Now, I wouldn't ask you guys to name to determine R or S in terms of the name, because we're not at that stage yet in organic nomenclature. That's something you'll learn in organic chemistry, but there needs to be an R or an S added to this name because it's chiral. And in order to do that, I'd actually have to assign priorities for these different groups hanging off of it. I'm trying to look up real quick how I do that because I don't remember. This was my worst thing in naming stuff anyway. Uh, okay. So in this instance, the highest priority would be based on the rules. This would be priority 1, priority 2, priority 3, priority 4. So basically, the longer the carbons, the higher the priority. Okay. And then if the highest priorities go clockwise, then it is priority 1 to 2 to 3 to 4 clockwise. It is R. If 1 to 2 to 3 to 4 is counterclockwise, it is S. So this, technically based on those rules, would be named R2-ethyl pentane. Now, like I said, I'm not asking you guys to name R and S. I'm just asking you to recognize that there's a chiral center. But that's how you go about doing R and S. But that second part can be really complicated to be able to visualize, and that's why I'm not asking you to do it yet. But generally speaking, for any long chain system. So let's just let's have a little fun. Let's look at all possible isomers of C9H20. Okay. So the first and in order to do this, I'm going to simplify it. Where did the 2 in front of the name come from? I have to tell, where is this ethyl attached to? Which carbon on this chain is it attached to? So carbon 1, carbon 2, the ethyl is attached to the carbon 2. So 2-ethyl. So let's practice. This is a good way to practice. Make up an alkane. C9H20. That's an alkane. So let's see how many different things I can draw that have 9 carbons in them. This is a good practice. I recommend practicing this way. It's very good. It's very good practice. So I can go carbon, then CH2, 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 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 carbons. Here's how a chemist would normally draw that. 1, 2, 3, 4, 5, 6, 7, 8, 9. These two represent the same thing. So this is nonane. Okay. Now I'm going to take 1 carbon off of this long chain. So that would be CH3, CH2, 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 1, 2, 3, 4, 5, 6, 7, 8. But now I have a carbon because I have to have C9. So I can hang it off of here. Need to get rid of this one of the hydrogens, so that still gives me 4 bonds. I could doesn't let me erase them. Damn it. I was hoping so. So, I'm going to do that. I just need that. So now I could also, oh, I can't erase. Sorry. I was trying to shortcut it, but and hang the methyl off of this carbon. That's C9. I can hang it off of this carbon. And then I can hang it off of this carbon. But let's talk about this one. So let's look at these two. Okay. If I numbered this one here, 1, 2, 3, 4 carbons. So this is 4-methyl octane. Methyl group hanging off the 4th carbon of an 8 chain. Now, I didn't bother to do this, but I should have if I'd numbered from this way. 1, 2, 3, 4, 5. Which number do I use? Why is this not 5-methyl octane? It's not 5-methyl octane because 4 is a lower number. And you always number the chains so that the number that you give to the substituent is lower. Now, if I do the same thing on this one, I have 1, 2, 3, 4, 5. And if I number from the other direction, I have 1, 2, 3, 4. Now, the lower numbering is from right to left. So this is also 4-methyl octane. In other words, these two are the same. And that means I am through with the different isomers that I could create by just pulling one methyl group off the chain. So let me go ahead and number this one. This is 2 methyl octane, and this one is 3 methyl octane. Okay, so that's pulling one methyl group off. Now, what if I pull 2? So I have CH3, CH2, 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 1, 2, 3, 4, 5, 6, 7. So that means my base name is going to be heptane, and I've got to put 2 additional methyl groups on. So I could do that this way. Four bonds to carbon. And now that I have 2. And now I can leave one of these methyl groups on and move the other relative. One, two, three. Yeah, okay. Just checking. So that's one way, and I can keep moving this, these relative to each other. So now I could have also just moved them together. One, two, three, 4, 5, 6, 7. And that's kind of the center, so that's where that ends. Or I could have done it as an ethyl group. Now, with an ethyl group, the first place I can legitimately put that, and it not be another place, is on the second carbon. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Oop, I'm off by 1. So, there. If I put it here, I have one of the ones I've already drawn. And you can verify that statement. So then the other place I can put the ethyl group is there. And that's all of the possible ones that have ethyl. And I can keep going. Although there's a limit to how many I can pull off and still have short things. So I can now pull off 3 carbons, have a hexane, and have a whole bunch of isomers of hexane. But all of these have the same C9H20 molecular structure. So how do I go about naming these? This one, 2 methyl groups on the 2 carbon. So this is 2,2-dimethyl. 2, 3, 4, 5, 6, 7. Hexane. Heptane. It's a 7. This is 2,3. And so forth. That's how you name that. Now, how many of them do I have? So, how many different molecules can I draw for C9H20? Just Googled that. So C9H20 has 35 isomers. So that means there are 35 different ways I can draw bonding that has 9 carbons and hydrogens. This is the reason why carbon chemistry is so complicated and why the rules for naming have to be so complex. But this is also the reason why in chemistry we do emphasize nomenclature, and you have to truly be able to recognize and do nomenclature. This one would be 1, 2, 3, 4, 5, 6, 7. So it's a heptane, and 1, 2, 3, 4. So this would be 4-ethyl heptane. So if you're really needing to practice this, just write out a like octane C8H18 or decane C10H22 and draw all of the isomers, as many of them as you can think to draw, and then name them, and then check to see, do your names match? Because you can Wikipedia, what are the isomers of octane, and see if you manage to get all of them. It can be a really good way of practicing alkane nomenclature. Now, it gets really annoying to draw them like this, So I recommend you also practice drawing them the way we draw them. We draw them as chemists. So this we would draw as 1, 2. So this is a heptane. 1, 2, 3, 4, 5, 6, 7. Oops, off by 1. That's 1, 2, 3, 4, 5, 6, 7. And on the 1, 2, 3, 4th position, 1, 2, 3, 4, I have an ethyl group. So these two things represent the same compound. The lower one with all of the carbons written out, that's how we would write it in freshman chemistry. The upper one that's just lines, that's how you write it in organic chemistry. And how you're going to see it in like biology textbooks or any upper level book, you're going to see it as that line drawing, not as that all those letters. So at 114 level, it's time to kind of transition between the two. She'll be right back. I'm just going to go get my dinner. as many as Isrod, look, I sense that you are incredibly anxious about this course and the amount of work it takes for this course, based on how many times you've asked about homework and how many questions and so forth. This course is a 4 credit hour course. That means you should be spending 13 hours a week working on it. So, if you do not have 13 hours a week to work on this course, you may not have enough time. I will be asking enough questions to verify you understand the material, as well and that you should be able to reasonably complete in an hour if you have done some of the homework before you came to class. That generally means between 10 and 20 questions that are show your work questions. Well, then you're well on the way to working through what you need to have done so that you'll be able to answer whatever I ask. Look, I wouldn't blindly just work problems. Oh, I got to work all these problems. That's not the way to approach this material. The way to approach this material is to read the questions and ask yourself, trust your gut. Do I understand what this question is asking of me? Can I get a feel for how to work this? Do I know, as soon as I read the question, do I know how to work it? In other words, as soon as I read the question, do I know what data I need and exactly how to approach the problem and work the problem? If the answer is yes, you probably don't need to work the question. If the answer is, oh my God, I don't have a clue how to start it, you need to go do some reading and go back to your notes and go back to the lecture to get an idea of how to start it. And if you still don't know how to start it, you probably should come and talk to me during one of these question and answer sessions to ask some questions about how to get started on a problem that you don't know how to start. If the answer is, I sort of know how to work it, but I'm not sure, those are the homework questions you should work first. So you shouldn't work the questions you already pretty confident you know how to work. The first questions you should approach are the ones you think you may know how to work, but you're not sure you know how to work. Then you should approach the ones you're not. If you don't know how to work a question, those are the ones you need to write down and ask in the question and answer sessions, in the question and answers for the course. I do not know how to approach working problem so-and-so in homework 1 or in chapter whatever. That's a perfectly valid question to ask in the question and answers for your question and answer points. That also tells me what things I might need to approach when I lecture the next time. And it's also something where I can at least, put a guidance or ask a question in the question and answer to see what you don't know. So that's a way to start a dialogue. But, so if you flat out just don't know how to work the problem, that means either one, we haven't covered it in lecture, Or 2, you don't understand what we did cover in lecture, and that's a question where you need to ask the question of me. I don't know how to start this. But if you have a vague idea, yeah, we covered this. I think I may know how to do this, but I'm not sure. Those are the questions to work first. And then the questions where you're like, oh, I know how to do that. If you know how to do it, work one to verify, yes, I got the answer that the book says I should get. And then after that, don't work any more of those problems. Because that's just a waste of your time. Your time needs to be focused on working the stuff you don't know, not the stuff you do know. Does that make some sense? And since every student's different, and every student has a different background, what they don't know and do know is different. So I just have to, provide a broad range of questions, and then you are going to have to learn how to discern which questions you need to focus on to learn. What do you need to be working on? This was an instance where Alex was okay at doing. I can work with anxious. It sometimes gets I get a little abrupt. Just ignore that. That's the autistic side of me. I'm not actually annoyed at you. I'm annoyed that I can't convey what I'm trying to explain better, if that makes some sense. And if you're prone to anxiety, the first couple of weeks of class, for any class, is an anxious time because you're not really sure how the class is going to work. So if you do happen to be highly anxious or have high anxiety, the first couple of weeks of class is just brutal. And I understand that too. So I'm on total screen. What am I supposed to be working on? Set up all live streams. That's what I'm supposed to be working on. To do that, I need the calendars. Sort it out, put a calendar up here. I handed out a calendar. closed off the music. Darn it. Listening to. So for those of you that are following, hey, the finished suggested homework 1 for student, congratulations. You got something scratched off your to-do list. You're very welcome, Rachel. Congratulations. So this ends the time for the first body doubling work along. I am proud of all of you that participated, and I hope you got your goals done. I am still working on mine.